Hello class, we are looking at the calculator practice on Desmos on how to do a linear regression. So easy. I am following the same example that you see on your video, but I want to show you a few extra steps that may be helpful in your practice. Again, go to the plus sign at the top left and we're going to click on table and we're going to input those same values that we see on the video. She has 0, 1, 2, 4, 10, 8, 15, 12. Then go to your Y1. You have 1, 2, 4, 6, 8, 9, 15, and 13. So we know that when we look at our x and y variables, we know that x is usually our independent variable and y is usually that dependent variable. So if you hear that, you know x is your independent and y is the dependent. As you can see, I see my scatter plot, and I can thicken up my graph by going to the wrench at the top right, and I'm clicking on projector mode, and that thickens up that graph for me. Another thing I want you to pay attention to on projector mode is to look at the x and y axis. You know, x axis represents your domain. That tells me what's my lowest and my highest point on the x axis I want to see on that graph. And y axis is going to tell you what's the range of the y. So vertically, I'm going to see what is my lowest point and what is my highest point. So when you look at your table and you start getting bigger numbers, like you get numbers like 2,000, 5,000, 6,000, 10,000, you have to adjust your settings for the x and y axis so you can see those points. If my points was in the thousands, I may want to do my x axis from 1,000 to 10,000. And my y-axis may be from 0 to something like 500 because those might not be in the thousands. But you have to pay attention to what your x and y values are saying, and that's how you fix your domain and range. Very important that you understand how to do that. I'm going to do the same thing that she did on the graph as well, but I want to show you I want to show you a few extra things too. To do the Y1, you're just going to click Y on the keyboard and then 1. It'll already make it a subscript. You have the tilde, so you go to ABC, and the tilde is on the bottom row, and you click on that tilde. Then go back to 1, 2, 3. We'll go back to ABC and do M, and we know M represents slope. You can go ahead and do X, and then 1, 2, 3, type in 1. And then we're going to say plus, go back to ABC, and then do B. So to do your numbers, stay on that 1, 2, 3. And to get your letters, you're going to click ABC. And again, when you click ABC, you see that tilde. And you have to type it in that way for a linear correlation so that you can see your line of best fit. And if you look at your R equals 0.9759. That is saying that that line is almost 98% accurate to those points. That's how close those points are to that line. So as you can see, when you talk about linear regression, the closer that value is to 1, because we know that 97%, 98%, and 1, which is equivalent to 100%. So the closer it is to 1, the better and the stronger the correlation is. And you have to recall what you learned back in algebra. We see that the points are increasing. So it has a strong positive correlation. If the graph, the lines are decreasing, it has a negative correlation. And the closer the negative number is to -1, the stronger it will be. But if your R is a number that's close to 0, that means it has a weak correlation. And we'll do some examples in this lesson today. So the closer the number is to 1, it has a strong positive correlation. The closer your R is to -1, it has a strong negative correlation. But the closer your R is to 0, it has a weak correlation. And we're going to see some examples of that in our lesson today. Another thing I want to talk about is another way that you can look for R. Another way you look for R is you start spelling the word correlation. You see C-O-R. If you notice the way that these letters are rolled, it's italicized. So that tells me that it doesn't recognize that command. So because it doesn't recognize that command, I need to keep typing. But when I type in the R, the second R, now it recognizes that command as a correlation. After that, you're going to put it in parentheses. So you're going to say parentheses. And I want to get the correlation for my table X1 and Y1. So I'm going to type in X1, comma, Y1, close that parentheses. And if you notice, if you look at R in your previous step, it says 0.9759. And look at your third step, it says 0.9758 and so forth. This is another way you can find R very easy. So if I'm trying to find out what my linear correlation R is, I can type this in very quickly. But step 2 is actually better because it shows you what R is. It shows you what your slope and your y-intercept is. And we know that M represents slope and B represents y-intercept. And it also graphs the equation of the line as well. Another thing you can do, and that's on the video, you can write an equation for this graph, but you got to recall what you learned back in algebra. We know that slope-intercept form is y equals mx plus b. So we're going to say y equal. They gave us m. They say m was 0.87963. And we know b plus, or if it was a negative, you could say minus, doesn't matter. 1.53241. And do not forget to put in that variable x because you want it in the form of y equals mx plus b. So if you notice, I got y equals mx plus my b. And it just traced that same line because we already had the line. So if I turn off part 2, notice the line is still there. If I turn off 4, then the line disappears. So we know that what I plotted on 2 and what I wrote on 4, they're the same line. So very easy ways that you can look at how to do a linear regression, linear correlation, R. Another thing that we're going to talk about in our next video is residuals. So to plot a residual, all you're going to do is go to step 2, and it says residual, E1, and it says plot. Just click on that plot. And now you see what your residuals are. And on that next video, you'll get a better understanding of what does residual mean. Very easy. It just tells you how much off that prediction is. That's it. But the video is going to explain it in a greater detail.